For this example, the factors of the denominator are as follows. For the factor x squared minus 2x plus 5, we can no longer factor it out into simpler factors. So those two are the only factors that we have. X and x squared minus 2x plus 5. Now, decomposing our integrand into partial fractions, we now get the following. So x cubed plus 10 will be equal all over x times x squared minus 2x plus 5 gives you the first partial fraction of a over x for our first factor over here. Now, as for your second factor, you now get the following. So we just copy the second factor out. And for our second factor, since the second factor is quadratic, our numerator looks like the following. So you have your b times 2x minus 2. The 2x minus 2 here, if you notice, is actually the derivative of our denominator. X squared becomes 2x once derived, and negative 2x once derived gives you negative 2, plus a variable of k. Multiplying both sides by the denominator of our original integrand, we get the expression x cubed plus 10 equal to the following. With that, again, we assign values of x so as to enable us to compute the values of a, b, and k. Let's say we have first x equals to 0. In that way, the b term and the k term will disappear. So letting x now be equal to 0, you have the following expression, which, when simplified, since this one and this one will disappear, you get 10 equals to 5a, or a is now equal to 2. Now let's assign yet another value of x. Let's say you have x equals to 1. In that way, when x is now equal to 1, our b term will disappear. Since 2 times 1, that's 2, minus 2 will be equal to 0. So assigning now x equals to 1, you get the following expression. Again, we note the b term disappears. And as for the a term, which is already computed, we put it in here, so a is now equal to 2. So with that, we can now compute the value of k, and our k is now equals to 3. Lastly, to compute the value of your b, we simply assign random values of x. So for this one, let's have x be equal to negative 1 to make it easier for us to compute. So when your x equals to negative 1, you'll get the following expression. Again, the values of the a and the k are already determined, so we need to put them in here as well. This is your a, and this is your k. So simplifying our expression, we'll get the value of b. So b is now equal to negative 1. With the a, b, and k terms already computed for, we can now integrate our integrand using its partial fractions. So going back into this one, you now get, from here, our partial fractions are the following. Let's break apart the numerator. The 2x minus 2, we keep it all together. So never break them apart. Because, again, as we noted, 2x minus 2 is the derivative of our denominator. So keep this one as a unit, as we did here. And the 3, we separate it to give us this third integrand. Now, integral of dx all over x will give us the ln of x. This one, since we already have the derivative of the denominator rather up here, this second integral is also a natural logarithm. And as for this one, for our third integral, all we need to do now is to try to complete the square over here so that this third integral can be evaluated as an inverse trigonometric function, namely the arctangent. So completing the square for our third integrand, we get the following expression for the denominator. And factoring this out, the x squared minus 2x plus 1, we now get our final answer, which is equal to the following.